Class 9 Subject Chemistry Chapter 1 Matter in Our Surroundings Module 2 Objectives. At the end of this class, you will be able to list the properties of solid, liquid and gas, to differentiate the three states of matter and to know the effect of temperature on change of state of matter. Classification of matter as solids, liquids and gases. Before we move on to the topic, let us see the meaning of two terms, that is rigid. Rigid means unbending or inflexible, and fluid. Fluid means a material which can flow easily and require a vessel or container to keep it. On the basis of physical states, all the matter can be classified into three groups: solids, liquids and gases. For example, sugar, sand, iron, wood, rocks, minerals and ice are solids. Water, milk, oil, kerosene, petrol and alcohol are liquids. Air, oxygen, hydrogen, carbon dioxide and steam are gases. Properties of solids. Solids have a fixed shape and a fixed volume. Solids cannot be compressed much. Solids have high densities. They are heavy. Solids do not fill their container completely. Solids do not flow. Their rate of diffusion is least. Properties of liquids. Liquids have a fixed volume, but they have no fixed shape. Liquids take the shape of the vessel in which they are placed. Like solids, liquids cannot be compressed much. Liquids have moderate to high densities. They are usually less dense than solids. Liquids do not fill their container completely. Liquids generally flow easily. Their rate of diffusion is more than solids. Properties of gases. Gases have neither a fixed shape nor a fixed volume. Gases acquire the shape and volume of the vessel in which they are kept. Gases can be compressed easily into small volume. Gases have very low densities. They are very light. A gas is much lighter than the same volume of a solid or a liquid. Gases fill their container completely. Gases flow easily. Their rate of diffusion is more than solids and liquids. Now let us see why solids, liquids and gases have different properties. Matter in all the three states, solid, liquid and gas, is made up of very small particles called as atoms and molecules. According to the kinetic theory of matter, the particles of matter are in continuous motion and possess kinetic energy. Some forces of attraction also exist between the particles of matter. These are called interparticle forces. Kinetic energy increases with increase in temperature. Kinetic energy is maximum in gases and least in solids. The following properties of particles decide whether a given substance will exist as a solid, a liquid or a gas. The spaces or distances between the particles. The spaces between the particles are the minimum in solids, a little more in liquids and the maximum in gases. The force of attraction between particles. The forces of attraction between the particles or interparticle forces are the strongest in solids, less strong in liquids and negligible in gases. The amount of movement of particles or kinetic energy of particles. The movement of particles is minimum in solids, more in liquids and the maximum in gases. The motion of the particles can be seen and compared in the three states of matter. Now look at the picture. You can see, if you take the example of solid, the particles of matter are closely bonded. Hence, the space between the particles is less as compared to the other two states. Therefore, the force of attraction will be maximum between the particles compared to the other two states. Now, if you take the example of liquid, there is little more space compared to the case of solid. So, hence the force of attraction will be less compared to the case of solids. And finally, if you take the example of gas, As there is lot of space between the particles, hence the force of attraction between the particles will be less or negligible compared to the other two states of matter. Let's sum up all the properties of solids, liquids and gases. Shape and volume. Solids have a definite shape and volume. Liquids, no definite shape but definite volume. Gases, neither definite shape nor volume. Compressibility. It's negligible in the case of solids as well as liquids, but it is high in the cases of gases. Intermolecular forces between constituent particles. It's very strong in case of solids, much weaker than in solids, in liquid, and in gases it is negligible. Fluidity and rigidity. Very rigid and cannot flow. Liquids less rigid and can flow easily. Gases no rigidity and can flow easily. Density. In case of solid it is very high, in liquid it's moderate, and in gases it's very low. Kinetic energy of particles at a given temperature. It is least for solids, more than solids but much less than gases in case of liquids, and gases have maximum energy. Diffusion. In the case of solids, it diffuses slowly, and in case of liquids, diffusion is faster, and in case of gases diffuse very fast. Intermolecular space between constituent particles. It is least in the case of solids, lesser in liquids, but more than that in solids, and in gases more than solid and liquid. Now let's see what is the common unit of temperature and the SI unit of temperature. Temperature. It is defined as the degree of hotness or coldness of a body. It is measured with the help of a thermometer. We can also say that temperature measures the extent of motion of particles. Now let us see the temperature scales in Celsius and Kelvin. Celsius scale. It is written like this, and Kelvin scale. It is written as boiling point of water is 100 degrees Celsius and 373 Kelvin. Melting point of ice is 0 degrees Celsius and 273 Kelvin. Absolute temperature scale. Kelvin scale is called absolute temperature scale on which the lowest possible temperature is 0. Now let us see the relation between Celsius scale and Kelvin scale. 0 degree Celsius is equal to 273 Kelvin. So K is equal to degree Celsius plus 273, or degree Celsius is equal to K minus 273. To convert a temperature on Celsius scale to the Kelvin scale, we have to add 273 to the Celsius temperature. And to convert a temperature on Kelvin scale to the Celsius scale, we have to subtract 273 from the Kelvin temperature. Let's do a problem. Problem. Convert the temperature of 25 degrees Celsius to the Kelvin scale. Now pause the video and see if you can do it yourself. Solution. We know that temperature on Kelvin scale equals temperature on Celsius scale plus 273. So 25 plus 273 is equal to 298 Kelvin. Let's move on to the next topic, change of state of matter. Interconversion of states of matter. The solid state, if you heat, it will move on to the liquid state, and liquid state if you further heat, it will change to the gaseous state, and vice versa is also possible. That is, if you cool the gas, it will move on to the liquid state, and if you further cool it, it will change to the solid state. The phenomena due to which matter changes from one state to another state and back to its original state on altering the conditions of temperature and pressure is called interconversion of states of matter, or it is defined as change of matter from one physical state to another. We can change the physical state of matter in two ways, by changing the temperature and by changing the pressure. In this picture you can see, if you take the example of ice, that on heating it, it will melt and change to water. Now if you take the example of water, if you are providing it heat, it will change to boiling water, and this boiling water, if you further heat it, it will give you steam. Now let us discuss the effect of change of temperature on states of matter. Solid to liquid change. It's called melting or fusion. When a solid is heated, the particles begin to vibrate with greater speed and begin to move more freely. Then at a particular temperature, the solid melts and changes into liquid. The process of melting is also known as fusion. The process in which a solid substance changes into a liquid on heating is called melting or fusion. The temperature at which a solid substance melts and changes into a liquid at atmospheric pressure is called melting point of the substance. The melting point of ice is 0 degrees Celsius or 273 Kelvin. The melting point of a solid is a measure of the force of attraction between its particles. Higher the melting point of a solid substance, greater will be the force of attraction between its particles. For example, the melting point of iron metal is very high, 1535 degrees Celsius. Melting point of wax is 63 degrees Celsius, whereas melting point of ice is 0 degrees Celsius. Now let us move on to liquid to gas change. It is also called as boiling or vaporization. The process in which a liquid substance changes into a gas rapidly on heating is called boiling. The temperature at which a liquid boils and changes rapidly into a gas at atmospheric pressure is called boiling point of the liquid. Boiling point of water is 100 degrees Celsius. Different liquids have different boiling points. Boiling point of alcohol is 78 degrees Celsius. Boiling point of mercury is 357 degrees Celsius. Look at this picture. You can see in the case of solid, in the cold condition, the particles are closely bonded. As you are giving heat, the particles will gain energy and start moving. And in the case of liquid, in the cold condition, there are some spaces, and when you are heating it, they overcome the other intermolecular forces of attraction and they start moving.